Finding an exoplanet is like searching for a needle in an endless haystack. This is the challenge that astronomers face every day in their quest to discover these distant worlds. But how exactly do they do it? Well, they've developed some pretty ingenious methods to find these elusive cosmic gems. The first of these methods is called the Doppler effect, or more specifically, Doppler spectroscopy. Imagine you're sitting in a park and you hear a car approaching. As it gets closer, the sound of its engine becomes louder and then softer as it drives away. That change in sound is the Doppler effect, but instead of using it to track cars, scientists use it to track stars. They look for tiny shifts in the color of a star's light, which can indicate that the star is wobbling due to the gravitational pull of an orbiting planet. Now, the second major technique that astronomers use is the transit method. This technique involves watching a star and waiting and watching some more for a very long time. They're waiting for a tiny drop in the star's brightness, which could indicate that a planet is passing in front of it. This transit, as it's called, can provide a lot of information about the exoplanet, including its size, its orbit, and sometimes even its atmospheric composition. Thanks to these techniques and a few others, scientists have discovered thousands of exoplanets in our galaxy alone. And with every new technological advancement, from more powerful telescopes to more sophisticated data analysis, we're getting better and better at finding these distant worlds. It's a testament to human ingenuity and curiosity that we've been able to turn the seemingly impossible task of finding a needle in an endless haystack into a systematic and remarkably successful hunt for exoplanets. It's a fascinating journey that's only just begun. So we've found them, but what exactly do we know about these exoplanets? Every exoplanet discovered is a new world, each with its own unique characteristics and mysteries. As we delve deeper into the cosmos, we encounter a dazzling array of exoplanets. These are planets that orbit stars outside of our solar system, and they come in all shapes and sizes, much like the planets we're familiar with in our own celestial backyard. Gas giants are the behemoths of the exoplanet world. Much like our neighbor Jupiter, these planets are primarily composed of hydrogen and helium. They can be several times larger than Earth, and their swirling atmospheres often display a mesmerizing array of colors and patterns. On the other end of the spectrum, we have ice giants. These are similar to gas giants, but with a higher proportion of ices like water, ammonia, and methane. Uranus and Neptune are the familiar faces in this category. Imagine a world where the skies are filled with clouds of diamond dust, and it rains precious gems. That's the reality on an ice giant. Then there are the rocky planets. These exoplanets are more akin to Earth, with solid terrestrial surfaces. The quest for finding a second Earth has led scientists to focus a lot of their attention on these rocky planets. The hope is that somewhere out there there's an exoplanet with just the right conditions for life as we know it. The possibility of life on these exoplanets is one of the most exciting aspects of this field of study. As we speak, scientists are constantly researching using advanced telescopes and innovative techniques to detect signs of life in these distant worlds. It's a painstaking process, but the potential rewards are immeasurable. Exoplanets are a fascinating subject, aren't they? They remind us of how little we know about this vast universe and how much more there is to explore. The journey to understanding these celestial bodies is filled with wonder and excitement, and every discovery brings us one step closer to answering the age-old question, are we alone in the universe?